Here are the answers to the review questions for the final exam, and I hope to have 4 parts of this. This is part 1, where I give you the answers to the first 10 questions. This is in order to save time and also to get you the correct answers and the method of doing it. Make sure you look at how the problems are worked out and prepare for the finals. The question 1, what's the difference between precision and accuracy? Accuracy is actually how close you get to the true answer or to the expected answer, how close you are. How close you are to the bullseye. But precision is when you repeat the experiment several number of times, how close all your answers are to each other. So if you are both accurate and precise, then the answers will all be close to each other and will also be very close to the expected value. What are the basic units of the SI? There are 7 basic units. They are meter, the unit of length; kilogram, the unit of mass; second, the unit of time; ampere, the unit of electric current; Kelvin, the unit of temperature; candela, the unit of intensity of light; mole, the unit of quantity of substance. What is the area of a circle of radius 1.2 meters? Area is pi r squared, that's given. Calculate that, and you notice that the number of significant figures there is just 2, so the answer should have 2, which is 4.5 meter. And then a car speedometer has 5% uncertainty. What is the range of possible speeds when it reaches 90 km per hour? So take 5% of 90 first, which is 90 times 5 by 100, gives 4.5 km per hour. And so the range must be 90 plus or minus 4.5. 90 minus 4.5 is 85.5. 90 plus 4.5 is 94.5. So that is the range. Convert 36 km per hour into meter per second. 1 kilometer is 1,000 meters. So 36 kilometers multiplied by 1,000 meters in 1 kilometer divided by 1 hour. And there are 3,600 seconds in an hour. The hour cancels, the kilometer cancels, and you get 10 meters per second. Question 2, what is the difference between speed and velocity? Speed is defined as distance divided by time. So speed is a scalar. It only has a magnitude and has nothing to do with direction. But velocity is displacement over time. And displacement is a vector. Therefore, that makes velocity also a vector. So again, distance and speed are scalar. Displacement and velocity are vector. Time again is scalar. Remember that. Okay, now it's acceleration. The initial velocity is 0. Acceleration is change in velocity divided by time. So it's 20 minus 0 divided by 60 seconds, which is 0.33 meter per second squared. That's the acceleration. And what is the displacement of the car during that time? So we're looking for delta x, which can be calculated using the average velocity multiplied by the time, which will always work if it's constant acceleration, which gives 20 meter per second divided by 2 times 60, which is 600 meters. Remember, you can use this formula. It's the average velocity because it's initial plus the final divided by 2. That is the average velocity multiplied by time. That is a quick and easy way of doing problems. Number 3, draw the velocity time graph of an object that is thrown vertically up from the ground until it returns to the ground. So when you throw the object up, its initial velocity is not 0. Because if it has to go up, you're going to give it some positive velocity. So let's say it's 20 meters per second. So it starts at 20 meters per second, and as it goes up, the velocity decreases. At the highest point, the velocity becomes 0. And then as it comes down, the velocity again increases, but in the opposite direction. And on reaching the exact same point from where you threw it, it's going to have exactly the same velocity in magnitude, but in the opposite direction. So if you threw it at positive 20 meters per second, when it returns to the same point, it's going to have a velocity of negative 20 meters per second. So keeping all that in mind, this is the diagram that you get. Because you see that at this point, the velocity is positive, let's say 20. And as time passes, the velocity decreases. So you see it's coming down. The velocity is 0 here. That's when it's at the highest point, and it's taken that much time to reach the highest point. And then that's the negative of the velocity axis. So you see that that's going to be negative 20. And surely it must take the same amount of time from the highest point to reach back. And interesting enough, if you take the displacement of this little triangle here, and you see you could make another triangle here if you drew that vertical line, both of these will have the same areas, except that one is positive, the other area is negative, and if you add them, you get what? 0. Yes, because the area of the velocity time graph gives you displacement, and in this case, we know that the displacement is 0 because it returned back to its starting point. And as you know, displacement is the shortest distance from the starting point to the finishing point. In this case, it returns to the starting point, so the displacement is 0 and the total area is 0. That is cool and can be understood. Okay, in the B part, you have to calculate the height of a cliff if it takes 2.5 seconds for a rock to hit the ground when it is thrown straight up. The initial direction is taken as positive, so the velocity is positive. It's 5 meters per second. Time is 2.50 seconds, but since it's going up and it's going to decelerate, g is negative 9.8, and that multiplied with half. That's why you have the negative there, and then you have 2.5 squared. You calculate all that, you get negative 18.1 meter. The negative just shows that it's coming down. It's moved down by 18.1 meters. So the height of the cliff is positive 18.1 meter. And it says, how long would it take to reach the ground if it is thrown straight down with the same speed? Okay, now you got to find time. You know delta y is 18.1 meter positive. So that's 18.1 is the same velocity, so it's 5 meters per second. We're looking for time. This time it's plus 9.8 because it's coming down. Okay, and when you rearrange and calculate, you get a quadratic equation here. And to find the root of quadratic equation, just look at the video for Basic Math Part 2. If that's not clear, search for the video Basic Math Part 2, where I'm clearly telling you how to find this, the the roots of a quadratic equation. Okay. It's minus b plus or minus square root b squared minus 4ac by 2a. Did it sound like Greek? I was fast. Go back to basic math part 2 video and you will see it. Anyways, here you get the time as 1.48 seconds. An Olympic track runner starts from rest and has an acceleration of 1.3 meter per second squared for 3.9 seconds, then has zero acceleration for the remainder of the race. Find the runner's speed at 2 seconds and at 4.5 seconds. Yeah, okay. Initial velocity is 0. You got to find the final. After 2 seconds, the acceleration is 1.3 meter per second squared. Time is 2 seconds. 2.6 meter per second. But now, the second part is a trick part to check whether you're reading the question. Remember that. The runner is only accelerating for how many seconds? 3.9 seconds. And after that, the runner is moving at a constant velocity. So whatever is the velocity at 3.9 seconds, that's going to be the velocity even at 4.5 seconds. Because his velocity does not change after that. So we just need to find the velocity after 3.9 seconds. Same equation, except time is now 3.9, not 4.5. I hope you understood. So you get 5.1 meter per second after 3.9 seconds, which will be the same after 4.5 seconds. Okay. The fifth one, the object is dropped from a height of 75 meters from above the ground level. Find the distance traveled during the first second. Find the final velocity at which the object hits the ground, and also find the distance traveled during the last second of motion before hitting the ground. Okay. Whenever you hear that the object is dropped, that means its initial velocity is 0. Okay, so you got to find the distance, delta y, it's v naught t plus 1/2 a t squared. Initial velocity is 0, making the whole first term 0, and then half times 9.8 is 4.9. And you have to find the distance during the first second, so time is 1 second. Which gives 4.9 meter per second. In the B part, you have to find the final velocity. Now we can use the equation v squared is v naught squared plus 2a delta y. Initial is 0, a is 9.8, and delta y is 75.0 meter. Get 1470. But you got to take the square root of that, and that will give 38.3 meter per second. C part, you got to find the distance traveled during the last second of motion, and we do not even know how many seconds it'll take to hit the ground. So first we'll find the time taken for it to hit the ground. We'll use this equation because we know delta y is 75 meter. Initial velocity is 0, and we can find the total time taken for it to hit the ground. Take the square root of that. Now since we know that it takes 3.91 seconds, we just need to find the distance traveled in 2.91 seconds and take the difference. Same equation again. Why are we finding the displacement in 2.91? Because if you take the difference, you will get the distance of displacement in the last second. So it is 75 minus 41.5 meter. You may not be able to see that clearly, so I'm going to say this. It's 33.5 meter. Again, it's 33.5 meter. Okay, in the sixth one, a projectile is launched at ground level with an initial speed of 50 meter per second at an angle of 30 degrees above the horizontal. Calculate the time taken by it to return to the ground and the maximum height reached. Whenever a projectile returns to the ground after being launched from the ground, what is its vertical displacement? 0. It started from the ground and comes back to the ground. Okay, this is two-dimensional motion, so there's going to be delta x and delta y. Delta y, which is the displacement in the vertical direction, is 0. So first of all, make the diagram. That's the path taken. The speed is 50 meter per second at an angle of 30 degrees. Break it up into its two components. The horizontal is 50 cos 30 and the vertical is 50 sin 30. First, we talk about the vertical. So, delta y, vertical is 0. As I've explained, A is negative 9.8 because first it's going up. And we're only interested in what's doing in the beginning. It's being projected up. So it's negative. And okay, the vertical component is 50 sine 30, which is 25. And we're going to find delta t. Equation we're going to use is delta y is v naught t plus 1/2 a t squared. Delta y is 0. V naught y is 25 delta t, okay, becomes negative 4.9 because a is negative 9.8. Rearrange that. The t squared and the t will get cancelled. And you get the time as 25 by 4.9, which is 5.10 seconds. Next, you have to find the maximum height reached. Okay, in the B part, to find the maximum height reached, use delta y is v naught t plus 1/2 at squared. So that is 25 times 2.55 seconds. Why 2.55? Because that is half of 5.10. Because if the total time taken is 5.10 seconds, in order to reach the maximum height, it's going to take only half of that time. Is that clear enough? And then negative, because first it's going up, 4.9 times 2.55 squared. When you calculate that, you get 31.9 meter. And then in number 7, an archer shoots an arrow at 78 meter distant target, the bullseye of which is at the same height. Okay, here again, it's at the same height as the release height of the arrow. So what is delta y? I mean along the vertical direction. Yes, it is 0. And says what angle must the arrow be released to hit the bullseye if its initial speed is 35 meter per second. This question has more math in it. Okay, he fires it from a little height, but A and B are at the same horizontal level. That's why delta y is 0. And again, 35 can be resolved into two components, which will give you 35 cos theta and 35 sin theta. This is the equation again. Delta y is 0, talking about the vertical quantities. And what is v naught? Is the vertical component, which would be 35 sin theta multiplied by time minus 4.9 t squared. And we can find time Remembering that the horizontal displacement is given, and if you divide the horizontal displacement by the horizontal component of the velocity, you're going to get the time. So it can be substituted as x by 35 cos theta. Again, on the other side is t squared, so square everything. Rearrange this, and that's the value of x that I've substituted. X is 78. You see the x here. So I've multiplied 35 with 78 and then put the sine theta there, divided by the cos theta and the 35. The 35s get cancelled. The other term, negative, becomes positive, and I take it to the other side. Again, there is x squared here, so that's 78 squared. And then 35 squared, cos squared theta. So the cos theta here and the cos squared here get cancelled, leaving one cos theta. So on the left hand side, 78 sine theta. And now I have brought this 35 squared to the left side with the cos theta. Okay, that's why you have it here. And this number is just what you get when you multiply 4.9 with 78 squared. So now 78 times this, 1225 is this. And now the math rule says that sine 2 theta is 2 sine theta cos theta. So since I see sine theta cos theta here, I can write that as sine 2 theta. Dividing both sides by 2. I could substitute this now as sine 2 theta by 2. Yes. And I've taken 95550 to the other side, which gives 0.312, and therefore sine 2 theta is 0.312 multiplied by 2. You see the 2 here. Okay. Take the arc inverse of that, you get theta is 19.3 degrees. 19.3 degrees. Now this owl is carrying a mouse to the chicks in its nest. It's 4 meter west, 12 meter above the center of the 30 centimeter nest, and is flying east at 2.5 meter per second at an angle 26 degrees below the horizontal. You need to visualize this, when all the direction, everything is given. So that is 4 meters to the west and 12 meter above. And that's how it's flying. 2.5 meter per second at an angle 26 degrees below the horizontal. And the nest is here, a circular nest with a diameter of 30 centimeters. Unfortunately, it lost the mouse. It falls off, and we got to find out whether it will fall into the nest. Using the equation, delta y is v naught t plus 1/2 at squared. Vertical displacement is 12. Fairly understandable. Get a quadratic here. Of course, the 1.1 t is 2.5 sine 26. And use the quadratic equation, calculate t. Get 1.46 seconds. And now, during this 1.46 seconds that the mouse takes to come down, we're going to find out how much it's going to move along the x-axis. Along the x-axis, remember that velocity is constant, so just multiply with the time. It's the cos component and you get 3.28 meters. Sorry, because 3.28 meters is not enough. The distance is 4. Even if you subtract 0.15 meter, which is radius, still not going to make it. It will not fall into the nest. The chicks will go hungry. Okay, now here you have a dog running around. Goes 3.5 meters to the south, 8.20 meters northeast. Okay, so AB is to the south. BC is to the northeast, that's 8.20 meters, and CD is 15 meters to the west. And the resultant displacement is AD. Well, that angle is 45 degrees because it says northeast. So we got to find AD. The idea in this case is to split each displacement into the x and the y components. Now AB is completely along the y, negative y. So the only one we have to split here is actually 8.2, which is resolved into 8.2 sine 45 and 8.2 cos 45. Both of them have the same value. Get 5.8 meters. So in the first case, as it goes from A to B, there is no x displacement. It's negative 3. It's negative 3 along the y-axis. 3.5, I mean. That's AB. And but for BC, you have 5.8 meters along the x, that's positive, and positive 5.8 meters along the y. And for CD, it's negative 15 meter, and along the y, it's 0. Now add them up individually. X is negative 9.2, y is positive 2.3, and to find the resultant, square root x squared plus y squared. Okay, so square both those numbers and take the square root. Gives 9.48 meter. Takes us to the last question. And the place kicker kicks a football from a point 36 meters from the goal. The ball leaves the ground with a speed of 20 meters per second at an angle of 53 degrees to the horizontal. By how much does the ball clear or fall short of clearing the crossbar? Nice question. Let's get the diagram first. That's 36 meters away. That's the goal post there. 3.05 meter high. That's where he kicks it from at 20 meter 53 degree angle. Once again you resolve it into horizontal 20 cos 53, vertical 20 sine 53. So first let's find the time taken for the ball to move 36 meters along the horizontal. What do we know about the horizontal component of the velocity? That it never changes. Yes, so to find the time, you just got to divide 36 meters divided by VOX, which is 20 cos 53. Because time is displacement by velocity. So 20 cos 53 is 12 meter per second. And so time is delta x by VOX, which is 36 meter divided by 12 meter per second. That gives 3 seconds, 3.0 seconds. And now we'll find the delta y during that time using the equation that has been used a million times now. Initial vertical velocity 20 sine 53. We're trying to find the vertical in 3 seconds. You know why it's negative? Because it's first going up. First term is 47.9. Second is 44.1. The difference is 3.8 meter. So surely it clears the crossbar. By how much? By 3.8 minus 3.05 meter. By 0.75 meter. And it's definitely while falling, because the total time that it takes, to hit the ground is what I'm calculating now, because remember I've taken delta y as 0 because it falls to the ground. I'm finding the total time. That's only 3.25 seconds. And it reached the goal in 3 seconds, so it's more than half. Therefore, it clears while falling. Thank you, and I hope you make good use of Part 1 review for final exam and expect 3 more parts if I can make it. Thank you.